Well, Pete, it's December 2022, last month of the year, with some interesting things to look at. Let's start with the inner solar system. Mercury is an evening object now, but it's not very well placed at the start of December. It's not too far from the planet Venus, but greatest eastern elongation occurs on the 21st of December, where Mercury is separated from the Sun by 20.1 degrees. So
that's a fair distance, actually, isn't it?
That's pretty good.
Yeah.
But Venus isn't too far away from Mercury during this time, but still quite low down.
Yeah. On the 29th of December, mag plus 0.6 Mercury and minus 3.8 Venus appear 1.5 degrees apart. That's quite close. And they will be low above the southwest horizon after sunset. And on that date, on the 29th of December, Mercury sets nearly 90 minutes after the Sun. So that's the best sort of time to look for it, towards the end of the month. After greatest eastern elongation, I would say, because you've got a balance point as the planet appears to get dimmer and becomes harder to see, but it's a decent distance from the Sun. Now, Venus, as we've mentioned, is quite close to Mercury, but you won't be using Mercury to find Venus. It'll be the other way around, because Venus is really bright at mag minus 3.8. And it's quite exciting that it's actually visible in the evening sky, isn't it?
It is. Before October, so the planet was at superior conjunction on October 22nd, so the Sun was between us and Venus.
Yeah.
And on that day, Venus passed from the morning sky into the evening sky. And it's nice to have Venus back as an evening object. As we go through into winter, it will get reasonably well placed in the evening sky for us to observe, and it's nice to have it back.
I completely agree.
It will get larger in apparent diameter, and the phase will now start to decrease as it comes towards us.
Yeah, well, on the 24th of December, there's a 2% lit waxing crescent moon, which will sit below both Venus and Mercury, but it's very low after sunset. So go out and see if you can see that if you've got a nice, clear, crisp December evening or afternoon. The planet Mars. Have you been following Mars, Paul?
You know I have been following Mars. I have been following Mars in July. Unlike you, I don't just wait until opposition. So, which brings us neatly to the point of this month. Mars is at opposition, so due south at midnight and at its closest approach. This is going to be very good. Mars reaches opposition on the 8th of December.
Yes, it does.
Unlike a lot of the previous couple of apparitions we've had where Mars has been very low down in the sky, it's going to be reasonably high up and a good apparent diameter, 17.2 arc seconds.
Yeah, which is great. Actually, it's closest to us on the 1st of December. Opposition occurs about a week later on the 8th of December. And it'll be really bright and quite salmon pinkish in colour. When I say bright, it'll be about mag minus 1.9 and will be amongst the stars of Taurus, which is a fantastic bit of celestial real estate.
It is, and it's a constellation which gets high in the sky, so that's pretty good. We've had some exciting things happening on Mars. In September and October, we had a dust storm that blew up, and it was a large regional dust storm, and it left a lot of the features changed in subtle ways, although some of them not so subtle. And there's still deposits. There were still deposits of bright orange dust in Argaea and Hellas in October. So it'd be interesting to see, as the dust settles, what effects this will have to the dark albedo features, which should by now be visible even in quite small telescopes.
Yeah, well, there's also another really special event happening with Mars this month, because the moon will pass in front of the planet, as seen from the UK, which is quite rare, actually. A lunar occultation of a planet isn't very common at all. And to get the moon passing in front of Mars isn't particularly common. I've never seen that, actually.
No, me neither. And it's been new for me.
Well, it occurs on the opposition day. So the moon's phase will also be representative of the moon being at opposition, which is full moon. So it's going to be quite exciting. The event occurs with Mars disappearing behind the lunar limb at around about 4 minutes to 5 in the morning. And that time will vary by a few minutes, depending where you live, because the moon is close enough to us to appear to move about in the sky due to parallax. So wherever you are, the moon's position shifts slightly in the sky, and that affects the timings.
Yeah, that'll make quite a difference. So it is well worth checking. You can always use your planetarium software or WinDewPost. If you put your lat and longitude in, it will work out what your sky should look like, and you can use those to get correct timings.
To be honest, if you go out at 4:30 in the morning and you look up at the moon, you won't be able to miss Mars. So basically, if that's the case, then just look at Mars with a telescope, binoculars, or even a naked eye and stay with it. And then you'll see it disappear behind the moon's edge. And it's very convenient because it takes about an hour for the moon to pass fully across in front of Mars. So you can go and make a cup of tea, do whatever you want, and then an hour later, the planet will reappear again. And because Mars has got a decent apparent size of 17 arc seconds or so, it will take, it's about 30 odd seconds, I think, for it to disappear and to reappear again. So that's going to be pretty good.
It is. I'm hoping for clear skies for that, because like you, I've never seen an occultation of Mars by the moon before.
No.
So let's hope for clear skies. Shameless plug. You can read about this in the Sky at Night magazine.
Yes.
I covered it in a previous issue about what can be seen on Mars over the next few months, and of course, your Sky Guide will have this in there. All right, let's move on out to the planet Jupiter. It's hanging around, isn't it, Jupiter? I'm quite impressed by just how long it's still persisting. It's a magnificent evening planet. It's quite bright, minus 2.5 magnitude on the 1st of December, and still plenty of interesting things to see on it. Have you managed to observe Jupiter much?
Yes, I have, actually. And it's interesting what you say about it hanging about. And that's a consequence of the fact that it is coming to opposition later in the year, because that means that as it would normally start to merge, if it was earlier in the year, merge into the summer evening and become later and harder to sort of stay with. During the autumn and into the winter, because the sky gets darker, it sort of gives the planets a bit of extra life, if you like, because the skies are darker to observe them. Yeah, I mean, you don't need absolutely dark skies to see the planets, but it does help to have a bit of contrast there. But yeah, it's been fantastic, actually. There's lots of detail visible on it, quite noticeable.
It really is. As I have noticed this year, there seems to be a lot more belts and zones in Jupiter's southern hemisphere than there used to be. And I'm really not sure about the names of them all now, because some of them have subdivided, and that southern hemisphere of Jupiter is very, very crowded now. So it'd be interesting to see what happens going forward. Planet Saturn, well, this is being affected by evening twilight as the month progresses.
Yes.
But it is still there. By the end of the month, it's magnitude 0.9, plus 0.9. And sits approximately 15 degrees above the southwest horizon by the time it finally gets dark. So, really, is the last of of what we're going to get out of Saturn.
Yeah, well, Uranus is there as well, and Uranus is very well placed. Actually, it reaches a peak altitude of 53 degrees, and Uranus will give you a test run for occultation observing, because it's occulted by a 94% lit waxing gibbous moon on the afternoon of the 5th of December. Now, disappearance occurs at 16:51 UT. Again, that time will vary because of the parallax issue with the moon and depending where you live, so go out much earlier. But having said that, 16:51, the sky isn't fully dark, so that's going to make this quite tricky to observe. And Uranus appears to go across a chord of the moon, so it's quite a shallow occultation angle. So you're going to need to go into the magazine to see roughly where the planet will be and see whether you can pick it up at disappearance. And if you can't do that, you might be able to pick it up when it reappears at about 1717 under darker conditions.
So quite a tough one, but an interesting one nonetheless. And then finally, Neptune is well positioned at the start of December. The evening twilight does begin to catch up on it. It's magnitude 7.9, so absolutely will need a telescope to see Neptune.
Yeah.
Despite this, it will get some 30 degrees in the sky under dark conditions all month, so that's not too bad. Won't see much on it, but imagers have been recording brighter regions on the disk. So if you've got an imaging setup, it's worth having a go.
Yeah, absolutely. It is a tricky world. Got some fantastic pictures have appeared of it, haven't they, from the JWST
They have.
setup. Amazing, absolutely amazing. Okay, well, let's go into the specials which are occurring this month. And I suppose we ought to mention that the annual Geminid meteor shower reaches peak activity around 1300 UT on the night of the, or on the 13th of yes, right. So the best time to see it is actually on the night of the 13th and the 14th of December. The peak activity is 1300 on the 14th. So it's not ideal in terms of that timing. Although having said that, the activity peak is fairly broad for the Geminids. But the biggest problem that you're going to have is that there will be a bright waning gibbous moon in the way, and that will reduce the number of meteors you see considerably.
Yes, a bit of a nuisance. I'm hoping our meteor cam will finally record some meteors in a meteor shower, but it will be affected by the moon. That's the problem.
Cameras actually fare better because the glare will knock out your visual acuity quite a lot. There's no way to sugarcoat that. It just does knock out all the faint meteors. But cameras, if the exposure is set so that it doesn't overexpose the sky, can still pick up trails fairly well.
Okay, so that's going to be worth trying. On the 15th of the month, Ganymede, the largest satellite of the planet Jupiter, transits between 1902 and 2202 UT. So that'd be a nice thing to watch out for.
Yeah, be good.
Should be visible in even small telescopes because Ganymede is a very large satellite.
Yes, it is. On the 21st, we have the December solstice. That's when the sun reaches its lowest declination, or most southerly declination in the sky. And after that, it will start to head north again.
And the lighter nights will soon be upon us. I say soon, it will actually take many months before we notice any difference. But
although it does happen quite fast, doesn't it? You
by
do
mid-January, I'm noticing the difference usually, that it's becoming lighter. Yeah. On the 22nd, the annual Ursid meteor shower reaches its peak activity about 10 o'clock in the evening. And the moon is new on the next day, the 23rd. So this year's display should be fairly favourable. There aren't lots of meteors with the Ursid meteor shower, but there are enough to make it worthwhile looking for.
With a new moon on the 23rd, it's you've got to get out if it's clear. It's actually a law in astronomy. It isn't really, but it would be nice to get some observations of the Ursids.
We also have on the same date, still on the 22nd, Ganymede transiting just before Jupiter sets. So the start of the transit is at 23:05, and the planet is setting shortly before Ganymede comes off the disk. So that'll be nice.
Yeah.
The 23rd, this is an interesting one. 9th magnitude comet C2020 V2 ZTF is just 4 degrees from Polaris this evening. That's pretty good. I mean, that really is almost overhead and well worth taking a look at.
Well, I wouldn't say it's overhead unless you're living at the North Pole, but
it's practically over. It's almost really quite high up. Stop being a pedant. You know what I mean? Compared to what we've had, a lot of stuff low down recently, that is quite a good altitude.
But there are two of those actually, because on the 25th, you've got
on Christmas Day.
Oh yes, that's right. You've got C 2022 E3 ZTF is predicted to reach mag +8, and as we go through into January, it will actually go, or is thought to be able to pass the naked eye threshold. Now, don't get too excited about that, because I'm not sure it's going to be something which is going to emblazon the night sky, but it should approach that threshold anyway, which means it'll probably be visible with binoculars, which would be rather good.
It's always nice to have a decent binocular or telescopic comet to look at. That's and anything else on top of that, if it gets really bright, is just icing on the cake.
Absolutely agree. Okay, well, let's go into the stars then. And December and January are the best months of the year for stargazing in the Northern Hemisphere, mainly because of the solstice, or the Northern Hemisphere's winter solstice. Or if you want to call it in general terms, it's the December solstice, because, of course, for the southern hemisphere, it's their summer solstice. That's complicated, isn't it? But that's for us in the northern hemisphere. It's when the sun gets to the lowest point in the sky. So when it sets below the horizon, and it doesn't stay up for the day for very long. When it sets below the horizon, it dips really low down. So the sky is nice and dark for a very long period of time. And that means you get opportunity to see a great swathe of stars. You can still see the stars of summer there. We got the summer triangle still visible. But the probably the best constellation on view, and we've mentioned it a lot, but it is worth mentioning, is Orion, of course, which is a beautiful and majestic constellation.
Yes, and it's quite unmistakable. Dominated, I think, really, most people notice the three bright belt stars first. And then
Yes.
in the top left, we have the orange giant Betelgeuse, and bottom right, we have the brilliant white star Rigel. Now, this obviously Betelgeuse has been in the news recently for quite a bit. So there was an interesting article published on the BAA website by Jeremy Shears about how the color of Betelgeuse has changed. There are some ancient records of it being a yellowish white color, not orange.
Right.
If that's the case, that means that Betelgeuse has only recently entered the red giant phase, and it will not be going supernova anytime soon. Certainly
I'm
not in our
very
lifetime.
surprised because when it started its last big dip in late 2019 into 2020, there were people who reported that they definitely knew it was going to go supernova.
Yes, stars normally go brighter when a supernova comes. They don't go dim. Yeah, I smile at that as well. When I saw those reports, it certainly is interesting to follow. It's a irregular semi-variable star, so Betelgeuse's surface produces lots of soot and dust, and this obscures the light that we see from the Earth. This is why it appears to dim.
Yes.
But it also does seem to change colour a little bit. So I think it's worth just keeping an eye on and seeing how bright it is compared to some of the other stars. But I don't believe it's about to go supernova anytime soon.
It'd be great if it did then, and we can come back to this and say you said.
Yeah.
But it's a massive star anyway, isn't it? It's about 1,000 times the size of our sun.
It is.
At that size, the edges of the star are ill-defined. They would be fuzzy, and I believe it has actually puffed off quite a number of shells around it, which have been seen. But yeah, it was a cloud of dust, obscuring dust, that caused the last dipping.
And we don't know when the next one's going to occur. In the opposite corner is, of course, the blue supergiant Rigel, one of the most luminous stars in our part of the galaxy. In fact, it's about 40,000 times as luminous as the sun.
Yeah.
And it really is quite a contrasting colour. It always looks bluish-white to me.
Yeah, if you just move your eyes backwards and forwards between it and Betelgeuse, then you'll see the colour difference quite markedly. But as you said, as we introduced Orion, you were talking about the three stars in the centre. They always surprise me because they are a very distinctive pattern, which is really odd because it's just three stars in a straight line of similar brightness and equally spaced. So you've got two stars at the end and one in the middle, basically. But it is really distinctive as a shape.
It is. It's very, very distinctive. And if you look at the belt through a pair of binoculars, actually, you can see lots of fainter stars. I believe this all forms the open cluster Colander 70.
Oh, yes.
So that's quite a nice thing to do. Binoculars are really good at this time of year, actually, because there's so many so many open clusters and things that you can take a look at in winter that it's you don't really need a large telescope. In fact, telescopes, what I find with open clusters, often don't do them any good because you zoom right into the centre and you don't see anything at all.
Yeah, that's right. If it's a big one like the Pleiades or whatever, if you put a lot of power on that, you just think, where have the Pleiades gone? You need to use low power. But yeah, binoculars are great. And of course, you can use binoculars to look at the sword of Orion, which hangs down from Orion's belt. And that's, I think, if you're a beginner in astronomy, this is probably one of the key regions to have a look at, and it's one that a lot of people are aware of. And of course, at this time of year when gifts are given, and if you do get an optical gift, that's the region to set your telescope up on and have a look at. And it just blows you away because you've got a couple of clusters at either end of the sword, NGC 1980 and 1981, if I remember correctly. And then you've got the large glowing gas cloud in the middle, which is Messier 42, which has got another little cluster inside it, which is the trapezium cluster. And of course, next to M42 and completely overshadowed, which is really unfair, is M43.
Yes, it's a shame that it's kind of overshadowed, but M42 is so glorious. I had one of my finest views of it actually last year in a particularly dark night, and I used my 12-inch Newtonian on it, and the amount of structure. It took ages to get it all down. It was really, really quite impressive. And I remember it's one of the first things. I'm sure it's the same for most people. It's one of the first things I looked at with when I first got a small telescope was the Orion Nebula in winter, because it really is easy to find, and always it doesn't matter if you've got a small telescope. It's so obvious a deep sky object.
Yeah, absolutely. It is. It's just beautiful. So if you've never seen it before, go out and have a look at it. And if you have seen it before, go out and have a look at it again. Okay, well, let's do some basic star hopping then, which is always useful, again, to beginners if you're not sure of how to get around the sky. If you go from Orion's belt up and to the right, as we see it from the UK, that's a northwesterly direction, you'll eventually arrive at the orange star Aldebaran, the brightest star in the constellation of Taurus the Bull. You might get a bit confused this time of year in 2022 because Mars will be in Taurus as well, but Aldebaran is the dimmer one, and it sits at the eastern end of one arm of a sideways V pattern of stars, which is the Hyades open cluster, and that's supposed to represent the face of the bull with Aldebaran as one of his eyes.
Yes, never quite seen that, but it certainly is a nice constellation, and the Hyades cluster, although again often overlooked because of the Pleiades nearby, is quite nice.
Yes, it is.
I am surprised I do wonder why Messier put M45, the Pleiades and the Hyades in his list, because there's no danger ever.
Well, the Hyades aren't in the Messier list, but the Pleiades are.
The Pleiades are. It's M45, and there's no way you could ever confuse M45 for a comet, really.
Well, the story goes that there was a competing catalogue, and Messier wanted to bump up the numbers, so he added a few extra bits in just to round it off a bit to
get the numbers up. Oh, okay.
But the Pleiades are fantastic. They are quite beautiful to look at. But if you follow the arms of the V-shaped Hyades to the east or to the left, as you're looking at it again from the UK, you'll eventually arrive at the tips of the bull's horns, which are marked by the stars Beta or El Nath to the north and Zeta to the south, which has got an official name. It is Tianwan is the name. Which I think means celestial gate. And just above that star is the first entry in Messier's catalogue, which does look a bit like a comet, and that's M1, the Crab Nebula.
Yes, this is the remains of a star which went supernova in 1054 AD and was recorded as a bright guest star. The Chinese, that's how they referred to supernovae then. And today, all that remains is this nebula and a pulsar spinning at the centre. So quite an impressive object. Although telescopically, it's got a very low surface brightness, so don't be surprised if you find it quite tricky to pick up.
Yeah, it looks a bit like a sort of... It's a quintessential fuzzy patch. It's a smudge of like a sort of slightly oval... it's more like a circle which has been squashed a little bit in shape. It's quite a... I'm not selling it very well, but it is a beautiful object to photograph if you've got a big telescope to look at. But I think it's more to do with what it is and the fact that it has, does represent a star which has exploded. In fact, I remember my days at university looking at photographs of the crab taken many years apart and overlaying them and then having to work out how the tendrils of material had moved over that period and working out when the whole thing had started off.
Yes, that's... an interesting project to do, and there has even now, if you compare photographs a couple of decades apart, it's obvious that there's been sort of changes in the nebula. So quite an interesting object. Taurus itself extends for the same distance to the rest, or to the right of the Hyades, as it does from the Hyades to the Horn Tips, and stretches across to another constellation, Cetus the Whale, which is a sort of large, indistinct constellation, but it is the home of an interesting object. This is the long-period star Mira, another red giant which slowly expands and contracts, and in doing so, its brightness and colour changes quite a bit.
Yes, it does. Well, actually, talking about that, if you go below or to the south of Orion, you'll find Lepus the Hare. And Lepus is a small constellation which looks a bit like an infinity symbol with ears. The ears supposed to be the ears of the hare. But it contains two objects, and this will have relevance to Mira with the reddish colour, because one of the objects is the globular cluster M79, which is pretty low for the UK. But the other one is the amazing red star R Leporus, which is also known as Hind's Crimson Star. And this is variable as well. And when this star gets to its lowest brightness, it can be it's pretty dim. I think it varies between about 5.5, so just on the naked eye threshold, to about almost mag 12. Over, I think it's 430 days or so.
Yeah, that's one thing these red giants have in common, these regular variables, is they do take a long time to expand and contract. So as a result, the periodicity, the time it takes to return back to the magnitude you started with, is often well over a year.
Yeah. Well, when it's at its dimmest, it appears redder than it does when it's at its brightest. And it is really quite a reddish coloured star. I mean, red is a bit of a misnomer, isn't it, when we describe red stars in the sky, because they don't look red. They look sort of orangey colour, like a glowing ember type colour. But some of them, like R Leporus, when it gets to very dim magnitudes, it
very deep red.
It can look a deep red, which is worth looking out for. Okay, well, Lepus, unfortunately for the hare, is being hunted by Orion in the night sky, and it's his two trusty hunting dogs that are helping him. That's Canis Major, the great dog, and Canis Minor, the little dog. And you can find Canis Major, courtesy of its brightest star, Sirius, by following Orion's belt down and to the left. So in the opposite direction you'd go to get to Aldebaran. And if Sirius is above the horizon, it's hard to miss, really, because it's really, really bright. And it tends to shine and flicker and show quite distinct primary colours as it does so.
Yes, this is just the Earth's atmosphere distorting it. Yeah. In reality, Sirius is a hot white star, a bit younger than the Sun. But there's when you've got bad seeing in this particularly turbulent, it can briefly look red and yellow and any number of colours.
Yes, it can. Well, there's loads and loads to see in the winter night sky, and as ever, go into the magazine, have a look at the Star Guide and the various articles in there, and they'll take you through what is visible at this time of year. So, wishing you clear skies, and if you do get clear skies, go outside and take in the feast, which is the December night sky. So thank you very much, Paul.
Thanks, Pete.